This assessment asks us to predict the product of the reaction on screen. Given that we have a ketone and hydroxide, we're led to believe that this is going to be an aldol reaction. Now, typically, ketones aren't great electrophiles in the aldol reaction unless we're heating the reaction so that the elimination step can occur. Good news, we have heat here, so this reaction will proceed. I'm not going to go through the mechanism entirely, except to draw the intermediates. This reaction is going to start by forming the enolate of the ketone. Now, we use the equilibrium arrows because hydroxide is not a particularly strong base. We're going to have mostly the unreacted ketone and only a little bit of the enolate. That works out for us, though, because now the ketone that has not become the enolate can instead be the electrophile. And so these electrons are going to come down to reform the carbon-oxygen pi bond, pushing out the CC pi electrons to attack the carbon. Let's go ahead and number our carbons here to make sure we don't lose carbons in drawing the product. So remember, we've talked a lot about, and I'm going to use different numbers, 6, 7, 8, 9, and 10. We've talked a lot about making sure that our understanding ends up with correct answers, and numbering carbons will help us with that quite a bit. Having numbered the carbons, we can say that we're going to reform the CO bond at what is carbon 1. And based on our numbering, we formed a new bond between carbon 5 and carbon 6. So this is carbon 6 that we formed our new bond with. What's attached to carbon 6? 7, 8, 9, and 10. And then 10 is reformed with 6. So there's our ring, 7, 8, 9, and 10. The other thing that's at carbon 6 is the O-. Our reaction isn't finished. We have water present, so we can protonate that to make the alcohol. I'm not going to show the arrow pushing, but I'll just draw the molecule. So we can eliminate or form the hydroxyl group here by reacting with water. And then in the final step, what makes this a favorable reaction is we're going to do the elimination. So how do we know that? Our kind of convention is that if the reaction is heated, we know that's going to cause the elimination. And so we can draw the elimination product. Again, not suggesting a mechanism here, but the elimination product is this. So if we look at what's happened, we've essentially removed a hydrogen in the hydroxyl group, the net molecule of water, to give us this product. And remember that elimination of water is the driving force for this reaction when ketones are the electrophile in aldol reactions. This is the product of the reaction on screen. And just to clarify, this is not meant to be a full arrow pushing mechanism. There are arrows that we haven't shown in here, but it still gets us to the correct product.